In this example, we want to describe the set of points in three-dimensional space that satisfies the equation x minus 2 quantity squared plus y minus 1 quantity squared equals 4, and to graph the set of points. If we first view this equation in the xy plane, we see that the equation represents a circle in the xy plane with a center of 2, 1, and a radius of 2. This is using the standard form of a circle where the center is identified by the values being subtracted from the variables, and the radius is the square root of the constant on the right-hand side. In this equation, there is no restriction on z. Therefore, z can be any value, positive, negative, or 0. And so we can visualize the set of points by taking the center in the xy plane and making a copy of it at every different possible value of z. When we do that, what we end up getting is a circular cylinder. This circular cylinder will intersect the xy plane in this circle, centered at 2, 1 and radius 2, and it extends indefinitely up and down along the z-axis. Here is a graph of the circular cylinder described by the equation. Notice that it intersects the xy plane in a circle centered at the point 2, 1 with radius 2. You can see this circle and the center of that circle shown in blue here. And the cylinder is formed by simply moving that circle up and down and creating an entire cylinder that extends in the entire z direction, both up and down. Next, we'd like to describe the set of points in three-dimensional space that satisfies the equation x squared plus z minus 2 quantity squared equals 16, and to graph that set of points. You can pause the video and try this example yourself, then resume the video to see the solution in a few seconds. Since our equation only involves the variables x and z, we first view the equation in the xz plane. Here it will be the circle with a center at 0, 2 and a radius of 4. And since there is no y included in this equation, y can take on any value once we move into three-dimensional space, and so we obtain a circular cylinder of radius 4 that's centered on the line with x equals 0 and z equal 2. This will be the cylinder formed by taking the circle in the xz plane and moving it along in the y direction and taking all points that we obtain in this way. Here is a graph of the equation in three-dimensional space. We can see the circle here in the xz plane, shown in blue, with the center of 0, 2 and a radius of 4, and that the cylinder is formed around that circle, extending in both directions along the y-axis.